So this is your X. Your y-axis. Okay, so this is your X. Right. So in shearing, there are only two types of shear. Okay. So I'm going to do positive shear. I'm going to do positive shear. So I'm going to teach you how the arrows are labeled. Okay. So over here, this is how positive shear look like. Okay. This is how positive shear look like. The shear stress. Okay. So this is how positive shear is. Okay. So this, I'm going to do this one first. So how to label? So this is shear stress. The plane, the intersecting plane is X, right? And the Y, I'll write. Okay, so shear. The intersecting plane is X, and the shear stress direction is in the Y axis, Y direction. Okay, so the X over here states the intersecting plane. So what do I mean by intersecting plane? This plane over here, right? It intersects the x-axis, yes or no? Right, that's why it's X. And then the Y is the shear stress direction. Right? So for this case, the arrow is pointing parallel to the y-axis. So likewise, over their side is the shear stress. Right? The intersecting plane will intersect the y-axis. The shear stress is in the x direction. Okay, so this is for positive shear. Okay, so in positive shear, right, how the element will distort. It will distort. So I'm going to draw in orange now the element distortion. Okay, so this is how the element will distort under positive shear. Okay. Then if we were to put this on Mohr circle, how does it actually look like? Okay, so this will be, again, I will label this that this is our point X. This over here is our point Y. And watch these terms, okay? So we know that stress X and stress Y is equal to 0, right? I did not draw anything, right? So if I don't draw anything, means stress X and stress Y equal. An important thing to note is the shear XY must be equal to the shear what? YX. So this is where it achieves the state of equilibrium. Okay, so there's no way that stress X, Y will be greater than shear stress YX. Okay, they always has to be the same. So if we go to Mohr circle, so Mohr circle, right? And this is where things get confusing. Okay, but you just have to hear me out. Okay, so we know that this is our normal stress, and this is our shearing stress. Element rotate clockwise and element rotate anti-clockwise. Okay, so we have to identify where point X and point Y are on this circle. So you know that our normal stress are 0, so this line over here is our stress X, and our stress X and our stress Y line. right? The axis of the shear, right? Then we have positive shear. But no doubt it is positive shear, right? You have to draw both positive and negative. And you will ask me, Eugene, if it's positive, why are we drawing on positive and negative? Just hear me out down here, okay? So where is point X? Okay, so point X, okay, on shear, okay, the rotation of the element determines point X and point Y. Okay. Okay. Have it has no relationship okay, it has no relationship with either positive or negative shear. Yeah. Let me explain what do I mean now, okay? So now we want to find where point X is on Mohr circle. Okay. So what I advise you to do is you pin this surface. So we're going to pin this surface or pin this point. Right. We're going to pin that point over here. And if we look at this arrow over here, right, it's going to rotate the element in the what? Anti-clockwise direction. Right. So when that's the case, over here, this will be your point X. Okay. Now, if we now look at point Y, and the stress on point Y, on acting on the point Y plane or intersecting plane Y, what you realize now is now the element will want to rotate in the clockwise direction if you pin the center like before, right? So this will be the location of your point Y. So from here, you can construct your Mohr circle. Okay, so at this stage, you realize that your stress average is equal to 0. Okay, so this term over here that I've written down here, this is important. I'm going to highlight in yellow. Okay, so this term over here, right, is important. Does not matter whether positive or negative shear. It all dependent on the rotation of the element. Okay, so I'm going to do another configuration which is known as negative shear. Okay, I'm going to do another configuration which is negative shear. Are you okay? Any of you have any question to ask? Anyone? I don't see anyone putting their hand or unmuting. Okay, so I'll do again in negative shear. Okay, I'll do again in negative shear. So next we are going to look at negative shear. Okay, we're going to do negative. So negative shear, again, the transformation is the same. Okay. So this is your element again. Right. So negative shear, it goes this way. So this arrow is shear, right? So if I were to draw our planes or our transformation, the center again, right? So this is our X and this is our Y. So over here, this is shear. The intersecting plane is for the arrow is X, right? And the shearing stress direction is in the Y direction. Over here, the shear, the intersecting plane is the Y, the shearing stress direction is in the X. Okay, so this will be our point X, and this is our point Y, and we realize that stress X is equal to stress Y, and this is equal to 0. Okay, so again, I will sketch how this element were deformed. Yeah, I'll sketch it out in orange. Okay, so this is how your element will deform. So later on, if you look at the notes, is opposite from positive shear. Okay. Why the element will deform there is because if you take these two with your left finger, this with your right finger, and you pinch the box, okay, pinch the element, this is how it will deform. Okay. So now we are going to draw this on Mohr circle again. All right. So this is your point, your normal stress and your shearing stress, right? And then element rotate clockwise, element rotate anti-clockwise, and this is where your stress X and stress Y line are, because it's on normal stress is equal to 0, and these two lines over here are your shearing stress magnitude. Okay, no doubt this is negative shear. You have to construct both positive and negative because it all depends on the rotation of the element. So now let's focus on point X. Okay, so if we pivot, okay, or put a pin on the center, right? So the X over here will, with this shear, will generate a rotation in a clockwise direction, right? So clockwise. So this is where our point X is, right? And then if we look at point Y with this line or with this arrow over here, it will generate a anti-clockwise rotation. Okay? It will generate an anti-clockwise rotation, right? So this is where your point Y is. Then with this, you can construct your Mohr circle. Okay, so that's how. So it's opposite from positive shear. If we quickly flash back to positive shear, the Y is on top, negative shear, the Y is at the bottom. Right, so now, okay, so these are the very basic rules of Mohr circle. Okay, so what I did not know when I was undergrad is I did not know the shear is determined by the rotation of the element. My prof did not tell us. Okay, he just said does not matter. It does matter. Okay, especially when we deal with composite material. Okay, like when you guys take 3C, how we orientate the carbon fiber or material that is inhomogeneous is important. If it's homogeneous, not important at all. Okay. Right. So let's look at an example where we combine normal stress and shearing stress together, which I did when we complete the previous example. Okay. So we are going to do, okay, example number 1. I hope I have enough space. I do. Okay. So example number 1 is we have an element